All right. So since your problem is just with Roman 2, then I'll just try to focus on Roman 2, which says sketch the graph of y equal to f of x. But I think I will also explain maybe Roman 3 after sketching. So how do I sketch this graph? Okay. Let me try to copy down. Let me try to copy it down on a paper so that when I'll be sketching, it'll be easier for me to be seen. So 3 minus x for x less than 1, 3 for x equal to 1, x squared plus 1 for x greater than 1. Okay. Now, alright, so I'll just do the little sketch here. So I'm going to draw my xy plane first of all. That is my xy plane. Now, we are going to draw the line y equal to 3 minus x, okay, for x less than 1. So how do I even draw a line? So my line is 3 minus x, all right. How do I even draw a line? First of all, for me to draw a line, all I need to do is I look for the value of y when x is 0. When x is 0, y is 3, so I put a point 3 there. Now, I look for the value of x when y is 0. When y is 0, x is also 3. I mark the 3 there. Then I draw a line that is passing through those intersection points. Alright, doing that, it gives me my line y equal to 3 minus x. But I'm drawing this line only for x less than 1, which means that since this is 3 here, this is maybe 1 here. When x is 1, y is 3 minus 1, which is 2. So it means that my line is going to begin from here. So my line is going to begin from this point when y is 2 and x is 1, going upwards. Alright, so that is going to be the line. Okay. Now, that is going to be our line equation. Now, the next one is y equal to 3 when x is 1. When x is 1, when x is equal to 1, y is equal to 3. So if you mark, you realize that it is just a point. All right, that is my point. Okay, that is my point. And finally, my y is x squared plus 1 when x is greater than 1. Now, when x is greater than 1, let's first of all draw x squared plus 1. Okay, it's a quadratic. So x squared plus 1 is our quadratic. All right. And this quadratic has since the coefficient of x squared, the coefficient of x squared is positive. It has a minimum turning point. And for us to get that turning point, we just need to look for the derivative. So the derivative will give us 2x. All right. When the derivative is 0, we are at the turning point. And x will be equal to 0. And when x is 0, y is 1. So the turning point is a point 0, 1. All right, so this is around 1 here, 0, 1. So definitely it's going to come like this and turn at this point and go back up. All right, that is my quadratic. But I'm plotting this quadratic only for x, that is for x greater or for x strictly greater than 1. Okay, for x strictly greater than 1, which means that let me try to indicate the portion we are plotting. Since this is x equal to 1 here, all right, we are plotting for x greater than 1. So it means that we'll normally have to begin from this point here going up. So this graph in blue is actually my graph. Now, when x is equal to 1 in the quadratic, y is equal to 2. So realize that the line 3 minus x and my quadratic intersect at that point. So my quadratic is going to start at that point. Okay, so that is my graph. So let me try to indicate now the graph that we have to draw in red. So we have this portion, okay, this portion, and then now with my little dot. But I really think that this dot is supposed to be y equal to 2 and not y equal to 3. All right, so that the dot should still fall on that point of intersection. But anyways, if this is actually the case, then the limit as x tends to 1 does not exist. No, the limit as x tends to 1 exists, but the function is not continuous at x equal to 1. For a limit to exist, right, as x tends to 1 from above has to be equal to the same as x tends to 1 from below. Now, if x is tending to 1 from above, we are concerned with a quadratic, which is this graph. All right, and you see that the function is tending to y equal to 2. As x tends to 1 from below, the function we are concerned with is this line, you realize that the line is still turning to y equal to 2. So since the left hand limit and the right hand limit are all the same, then the limit of my function as x tends to 1 is equal to 2. But the function is not continuous at x equal to 1 because of the fact that f of 1 is not equal to 2. Because for a function to be continuous at a point, we need that the limit at that point is supposed to exist and the limit is supposed to be equal to f of that point. All right, our limit exists, but f of 1 is 3 according to our function given, and since 3 is not the same as 2, then there is a point of discontinuity, and that is the point. So the function is not continuous at x equal to 1, but the limit exists.